Welcome back, everybody. In this video we are going to look at how we can get our raw JSON data and look at it in a nicer format in Spark. But before we do that, I figured we should probably talk about what Spark is.
What is Spark?
What is Spark? So Spark is... Oh, I'm on the wrong layer. It is a way of processing large amounts of data. And it's quite cool in that it can let you do loads of fun things with that data. So let's talk about how we're going to be using it first. So we've got our data over here in S3 in a bucket. Hopefully this will look like a bucket.
Looks like a database.
Put
Put the handle on the top. Yeah.
And now we have a bucket. Irrefutable bucket.
Yeah, I do believe that is a bucket.
Oh, we're just reaching for humour in this case. We're not doing a good job of it. Rightio. So Spark is a way of loading up very large amounts of data and spreading the work between lots of workers. So let's say you've got... it's supposed to be used for big data. So let's go, you've got 30 terabytes worth of data to process. It'd be great if your game had 30 terabytes worth of data to process, because that would mean you got a lot of users doing lots of stuff. Woohoo!
Or you've clicked P a lot.
Or you've clicked P a lot. Infinite loop of P sendage. That is just a really weird sentence. Alright, let's talk about Spark. So I'm going to create, or in this case, I've got this Spark driver. I'm going to call it Spark driver. Spark. In my very neat handwriting, I'm just the world's most lovely handwriter. That does say driver, Spark driver. Let's just go with it. So we are a little person and we send commands to the Spark driver. And the Spark driver, we might tell it, go ahead and read all of that very large amount of data from S3 and summarize it for me. Like tell me all of the level starts that we had. And it goes, no troubles at all. I will go to the driver and the command has come to me. I will go to S3 and I will get that data.
Yes. And
I actually won't read it myself. I will tell others how to read it. And it spins up a whole bunch of worker nodes. We're just going to write W for worker. Worker. And you can have as many of these worker nodes as you need in your cluster. And the driver is going to say, I can't give all of you the full set of data because that's too much to load into RAM. But what I can do is tell you to have a piece, and you to have a piece, and you to have a piece, and you to have a piece. So everyone gets a bit of the data, and they all process their part. And once they've reduced it down, they then go, hey, Spark driver, here are the results. And it gets the results back, gets the results back, gets the results back, gets the results back. The driver then collates them all together and said, and here is your final answer.
Nice.
But who says that there has to be an answer that comes back to you? It might say that summarized data might still be another 40 gig worth of data. Okay. So we go, well, we don't want to have to transfer 40 gig from the driver to our little laptop. Instead, we can say, and we'll take all that data, this big chunk, and we'll write that over to another S3 area. Does that make sense?
Yeah.
A little bit. So we tell the driver to do something, it goes and grabs some of the data, and it spreads the load to all of the other workers who then work on their individual chunk. Now, they don't have to know what anyone else is working on. They just have to do their part and then pass back their results. And that's really handy because it means we can now process more and more and more data. So we can come down here, and as another little example, let's say that we have time versus work. I should probably put that as nodes, actually. My eraser is not working. What is that on? Let's erase that out. Please. Oh, it's such a tiny little opacity. That would be why. Pick that up. Go away. I should have made that a hard line. Anyway. Alright, what should we call this one? Servers. Nodes.
Nodes.
So let's say that we've got one job. We've got one server. And this is 10 hours. We can have one server can take 10 hours to do the entire job. And if we reached all the way to the very end here at 9 hours and 59 minutes and then we ran into some trouble and we crashed, then the entirety of that 10 hours is going to be deleted and gone, which would be rather annoying.
Yes.
So instead, where Spark comes in is it says, how about we do this instead? Let's hide that layer. I probably could have done that differently. It's going to go like that. Time, nodes. We can say, let's have 10 individual nodes and spread the work so that everyone only takes 1 hour. 1, 2, 3, 4, 5, 6, 7, 8, whoops, 9, 10. Well done. So now we have...
Just as planned.
Just as planned, and that does say nodes. We now have the same amount of work being done, just spread across 10 servers instead. Which is quite cool. That means we can get through more data faster.
Good.
And then you go, well, surely this must come with a cost involved with it. And that's where Amazon really, this is where cloud computing in general really comes into play. Because you can get yourself a server on EC2 on Amazon, which will start up pretty soon, which will do that 10 hours worth of work for you. Or you can... And that'll be charged at whatever the rate is for that server. Let's say it's 40 cents per hour. So we'd have 40 cents. 40 cents times 10 hours is equal to $4.
Yes.
Or we could say, let's take that 40 cents per hour times 1 hour. 1 hour times 10 servers. And this is still equal to $4. So hooray! We can get the same amount of work done faster for the same price.
That sounds good.
That does sound good. Why are you sounding like,
I don't know reason.
I don't know, you're just a bit tired after lunch?
I guess.
Okay. It's very exciting. Nick, be more excited about this because been overboard. It means we can get 10 times the amount of work done in the same... we can get more work done in a shorter amount of time.
For the same price.
For the same price, which is really awesome. Which is what cloud computing's all about. It says turn on the server, do a bunch of stuff. As soon as you're done, turn it off, stop being charged.
Yep.
So hooray. So we're going to spin up a cluster in DataBricks. So, all right, let's talk about... That's a quick bit about Spark, which is what Spark is and how it does it. So let's go ahead. Now you can run Spark in different ways. You can go to Spark's website, spark.apache.org, and you can download the Spark application and run it locally on your computer. You could come here to Services and go EMR for Elastic Map Reduce.
Oh. Hadoop.
And this will spin up a Hadoop framework for a Hadoop cluster for you. You can say, I would like to spin up a cluster, and that will set up the leader node and the worker nodes for you. But Amazon does not have a free tier available for this, which is a bit of a bugger. But that's still no troubles whatsoever, because we can come to DataBricks, the community edition of DataBricks, community.cloud.databricks.com.
So I've heard Hadoop a lot.
Yes.
And I've heard you mention Apache Spark. How does that relate to each other?
Good question. So Hadoop... Originally, when Google said, we need to create indexes of the internet to make Google, yes, they needed to have a way that would map out that would make the entire internet indexed.
Mm-hmm.
So to do that, they thought we can have our one computer here or one server in the office control through the entire internet and can do a part of the internet.
Mm-hmm.
That could do the whole of the internet, but it would take a very, very, very long time to go through it all.
Mm-hmm.
Or what if we could farm the work out to lots of individual nodes who could report back to their leader how their individual piece of the internet did.
Yep.
So that was called MapReduce, because you take a piece of the data. Let's come quickly back here. I think I could scroll up, bring this one back in. And our lovely little diagram. They were telling the server, go and map out something. So it would take a piece of something and it would take that part, and that's considered the map option. This worker will take this piece of data.
Mm-hmm.
and it would send its data back to the driver, which was a way of they would all send their summarized results back to the driver.
Yep.
Now summarized because they'd taken the full data set and they'd reduced it down to a smaller data set, and now we can collate them back together and reduce it further to give a smaller answer. So map reduce is what it used to be called.
Cool.
Then someone said, you know what, I would like to not work for Google anymore, and I would like to open source this technology around to everybody. Yeah. And he called it Hadoop, or Hadoop, as it's supposed to be called. Just everyone called it Hadoop, and so that's the name of it.
Okay. Like GIF and GIF.
Yeah, pretty much.
Cool.
So then, now Hadoop did everything by writing it to disk. So it would say, I've got 30 terabytes. I will take a piece of stuff to this worker's disk. So it would have to go to the main RAID system and copy across part of the 30 terabytes. Now, how long does it take you to copy 15 gig from your laptop to your USB?
Many times.
Many times. It takes many times. It can take a while, yes. It can take a long period of time. So as data sources got bigger and bigger and bigger, and more data had to be transferred around, you had to be worried about how much network load was this pushing around the place.
Yep.
And then how big was the disk that you were writing to. And now it would have to copy from S3, take it to the worker, copy the actual physical thing to the worker. The worker would then have to load a piece of it, do the job, push it back to its own hard drive, read the next piece of that file, do what it needed to do, push it back to the hard drive. Now all of them each worker had to collate all of their all of their pieces of data back to some hard drive somewhere that the driver could then read off.
Yeah.
So loads and loads of time for transferring and writing and deleting and cleanup and loads of things like that. But then if, let's say, one of these workers came along and said, oh, no, I ran into troubles for some reason and I broke. Hadoop originally started off by saying, well, this guy just broke, so the entirety of the job just broke. Everything just died. The entire thing is now dead.
That sucks.
Yeah, so if that took a long time to happen, then, well, that's all the time that's gone. So Spark came along and said, yeah, I don't really like that idea of everything destroying itself if it runs into a problem. Now, okay, Hadoop does not have that problem anymore. There are plenty of ways to get around it with Hadoop. However, Spark was built to not have that problem. Spark says, instead of writing everything to disk and then loading up a bit and then writing it back to disk and loading up the next bit, why don't we just do everything in memory? So the Spark driver says, hey worker, go and load the bit of data that you need. And it would do that. It would bring out just that little piece that it needs and it would store it in memory. And it would operate only in memory. So all the operations suddenly got up to 100 times faster. So the speed of it is just wonderful.
Yeah.
So you get into this realm of, well, when should I use Spark or when should I use Hadoop? My recommendation would be that you always use Spark until Spark can no longer support what you need to do because your data is just so stupidly, oversizedly large that it just costs so much money to run on servers like that. And if you're reaching that point, then you are making loads and loads and loads of money. So it's okay. But really, I think Spark is the better way to go because it is more flexible, and you'll see that pretty soon, and it lets you work in more languages. So Hadoop was written in Java.
So you could only use Java?
You could only use Java.
That sucks.
Whereas Spark says, I'll let you use Java, or Python, or R, or Scala, or SQL.
I like all those things.
Oh yeah, it's great fun. And as you'll see, we're actually going to be switching from language to language on the fly. So does that answer your question?
Yes, it does. Good.
Very nice to hear. I am happy to hear that we have answered your question, Nick. So back into DataBricks. So first thing we need to do inside of DataBricks is we need to spin up a cluster. Now, if you don't have an account with the DataBricks Community Edition, sign up for one. It's free. And what this gives you is a free cluster to play with. Now, it's a one-node cluster. So our diagram here had a Spark driver with many workers. In this case, it's going to give us a cluster that is a one driver.
So it'll be much slower than it could be if you paid for it.
No, not at all. It's not going to go slower. It's just the size of it. So all we're going to get is a 6 gigabyte cluster. We're going to get a server.
So let's say if we got 6 gigs of data, it's just going to take up the whole thing. What if we got 7 gigs of data?
then it will spill itself over to disk.
Oh.
It'll say, well, I can't store all of this in memory, so I'm going to go back to the old Hadoop way, which is to load piece of it up, do what I can in memory, write it back to disk. So at that point, it'll start to get slowed down.
Okay.
You can try and load 6 gig of memory of data into memory at once, in which case it'll throw an exception and say, whoa, out of memory exception.
Yeah.
Or if you code it correctly, then it'll just go, well, I'll deal with this part on the this piece of the data, and I'll write that back to the disk, and I'll bring in the next piece and do it, and then write it. So at that point, it'll go slower. And if you're doing that, then it's time to switch over to the paid DataBricks edition.
Yeah.
Which is still pretty cheap.
So this has still got one node, but let's say we've got we're using DataBricks with multiple nodes, but you've got 6 gigs of data. It would still split those 6 gigs of data over the number of nodes that you have.
So it would split them off to the nodes if it needed to.
Right.
So it depends. So it's going to break up our data into chunks of 128 megabytes per chunk.
Okay. So it can operate quickly on small pieces.
Yes,
and get
absolutely.
On to the next piece.
Yep. And we'll see all this in action when we actually start getting going.
Cool.
Sounds all right. So inside of DataBricks, let's go. Any more questions, Nick, by the way?
I think I'm good for now.
Okay, cool. Awesome. So to spin up a cluster, if this is your first time logging into DataBricks, welcome to DataBricks. They have some notebooks on how to do. This is the icon for Scala, and these are Python. So there's notebooks you can go and learn how to do things. But we're going to come to cluster, and I don't think I've got a cluster started. No, I don't. Good old Jono's turned off at the moment. So we go to create cluster, please. And it says, cool, what do you want to call your cluster? What should we call our cluster? Nick, what's your favorite character's name? On the spot.
Geralt from Witcher 3.
Geralt. That was a great game.
I love that game.
Alright, so our cluster's name is going to be called Geralt. And it says, what version do you want to run this in? Now, just leave the default, but if you wanted to, then you could run in lots of different versions. Whoa. So you can say, I've written my thing to be using Spark 1.4 or 1.6, or I'm going to jump over to 3 beta, the version 3 beta. Or you can launch lots of different things here. So I'm not going to get into all this stuff. Let's just go with the default one. Yes, I want to use the default one, please. And you go, hooray, good. A free 6 gigabyte community edition, which will automatically terminate after 2 hours of sitting there doing nothing.
Sounds like more than enough time.
Sounds like more than enough time, absolutely. And if it turns off, you go, oh my goodness, my data. No, it doesn't matter. It's stored on S3. So we're going to load in the data that we need. Now, load in, not delete.
Sick.
Not move. We're just going to copy it. So then we can do whatever we need to. And then we can, if we wanted to, push the data somewhere else. Or we can just let the cluster die and then turn on a new cluster and go and read the data again.
Yep.
All right. Now, this is where we get into availability zones. Our S3 bucket.
Yes.
Our S3 bucket, AWS Unity Analytics, is in US East, North Virginia, whereas our clusters will be created in US West.
Oh.
So this means that there will be some charges involved, which is, when I said that this whole thing cost me 18 cents to build for the demo, that is where the charges came in.
Okay, so why didn't should we have made our S3 buckets in West?
Except we couldn't.
Oh, that's right, yeah.
The game analytics was already... So mobile analytics defaulted our S3 bucket to US East.
Okay.
But now Spark Community Edition is only available in US West.
Right, okay.
So when I said the whole thing cost 18 cents to build, it was because of network transfer. AWS says if you are transferring from any data that you need around the place in the same region, then there is no cost. So if we were doing stuff from Sydney A to Sydney B to Sydney C, we're all doing that within the same Sydney region, so there's no network transfer fees.
That's pretty sweet.
But because we're going to go from one region to another, it's now going to say, I am going to need to charge you a little bit of money for this. But what is the rate? AWS network traffic cost. I hope I find this. I probably should have re-looked.
I love how Azure comes up first.
Oh yeah, good old SEM payments. No, that's how much it's going to cost there. S3 network transfer
Costs?
data transfer costs.
Storage. S3 understand. Oh, okay. Oh, pricing. Cool.
Glacier, infrequent, standard, request. Where is the transfer? I really should have looked this up beforehand. I'm quite embarrassed about this. Inventory. Data transfer pricing. Here we go. So how much does it cost? So you can pick from and to. So where are we coming from and where are we going to? We are going from east. We're already on east.
Okay.
And we're going to
west.
Which is going to be north. No, not. That's.
So maybe we should change that to. Oh, another AWS
region. Here we go. We are going to be transferring at a rate of 2 cents per gigabyte.
That's nothing.
So very cheap. Very, very cheap. And our data isn't going to be that much really anyway. So what can happen if you get to the point where your network transfer fees are going to be costing you, wow, that's more than I thought it would be. Like that's more than 40 cents or 80 cents per session. It's time to switch over to DataBricks' paid edition. And then you can set up your cluster in whichever region that you want.
So you don't get charged for data transfer fees. Cool.
Yep. Okay, cool. So with that, let's start up our cluster.
Cool beans.
Now that's going to take a few seconds to start up, so we are actually going to finish this video here and come back when the cluster's up and running.
Sounds good.